Hello students, today I will discuss about the limit point of a sequence or cluster point. Here first of all we discuss about the neighborhood of any point. What is the neighborhood? Then the definition of the limit point. Now what is the neighborhood? Suppose I have a point C. We have to find the neighborhood of this C or any point. In general, we can take point C, and in particular, we can take any number. Suppose we take point C as 1. If we add a very small quantity is like 0.00001, so this becomes 1.00001, and if we subtract a very small quantity 0.0001 from this one, so this becomes 0.9999. So if we take this 0.001 is epsilon, if we take epsilon is equal to 0.00001, so this point is C minus epsilon and C plus epsilon. If we take this interval, that is open interval C minus epsilon comma C plus epsilon, then this interval is called neighborhood of point C. Now we have to define the limit point of a sequence. If we take any sequence Sn, if Sn is a sequence, and suppose C be any point of this sequence, and let C be any real number, then C is called limit point if neighborhood of C contains infinite number of terms. Of sequence. So definition of limit point of any sequence is Sn is any sequence and let C be any real number, then C is called limit point of sequence if neighborhood of C contains infinite number of terms of a sequence. That is, C is a limit point of Sn if Sn belongs to C minus epsilon, comma C plus epsilon for infinite values of n. So C is called the limit point of the sequence. Now if we take an example, such that if we take Sn is equal to minus 1 to the power n, that is, if we expand this, so this becomes minus 1, comma 1, comma minus 1, comma 1, comma minus 1, comma 1, comma so on. Now we have to check if we take any point 1 or minus 1, then is minus 1 or 1 is a limit point or not. Now if we take C is equal to 1, so we have find a neighborhood of 1, that is 1 minus epsilon, comma 1 plus epsilon. So here we see that the neighborhood of a C or neighborhood of 1 is 1 minus epsilon and 1 plus epsilon. In this neighborhood, there are infinite number of terms of a sequence is contained in this neighborhood, as like second term 1, fourth term, fifth, sixth term. We say this is second term, this is a fourth term, this is a sixth term, so on. So we see that there are infinite number of terms, as like second, fourth, sixth, eighth, 10th, and so on. So hence Sn is any term. Hence Sn belongs to 1 minus epsilon, comma 1 plus epsilon for infinite values of n. Hence 1 is the limit point of the sequence. Thus 1 is the limit point of sequence. Similarly, we can check that minus 1 is also the limit point of the sequence, that is minus 1, that is the neighborhood of minus 1, that is minus 1 minus epsilon and minus 1 plus epsilon also contains infinite number of terms. Hence minus 1 is also the limit point of the sequence. So there are minus 1, comma 1 are the limit points of minus 1 to the power n. This is the example of a limit point. Now if we take another example, as like Sn is equal to 1 by n, that is, if we expand this, which is 1, comma 1 by 2, comma 1 by 3, comma 1 by 4, comma 1 by 5, comma 1 by 6, comma so on. That is another term 1 by n, comma so on. So this is a sequence. Here we have to check which of the what is the limit point of this sequence. So if we see or analyze this sequence, is 1 is the limit point of sequence, Now check. If we take here, first of all, we see that this sequence is bounded as like we discussed this about the about the boundedness in previous lecture. So if we write this sequence, or if we take the range set or boundedness, so this is bounded and lower bound is 0 and upper bound is 1. So we can write this as 0, 1. That's like 1 by 2 here. 1 by 3 is here. And 1 by 4 is here. 1 by 6. So on. If we take the values, if we increase the denominator of the numbers, that is 1 by 7, 1 by 8, 1 by 9, 1 by 10. So the values approaches to 0, and here at 0 there are infinitely number of terms. If we find the neighborhood of a 0, so we get 0 minus epsilon and 0 plus epsilon. Here we see that in this area there are infinite number of atoms. In this area there are infinite number of atoms. So 0 is the limit point. And if we take any other point is like 1 by 2. If we take 1 by 2 and find the neighborhood of this, so this becomes 1 by 2 minus epsilon and 1 by 2 plus epsilon. So there exists only one point, 1 by 2. Similar, we can check other point. So here only one limit point, that is Sn is equal to 1 by n has only one limit point, only one limit point, 0. Now, so if we take another example such that Sn is equal to n, we can expand this as Sn is equal to n, and this can be written as 1, 2, 3, 4, 5, 6, so on. If we take any point and check whether it is limit point or not, so if we take 2 and as like this 1, 2, 3, 4, 5, 6, so on. If we take any point such that 3 and find the neighborhood, so this neighborhood becomes 3 minus epsilon, 3 plus epsilon. So here we see that in this neighborhood only one term 3 is find out, so 3 is the not limit point. Similar, we can check 4, similarly check 5, 6, so on. So there is no limit point, hence Sn has no limit point. Students, in next lecture we will describe about a very important theorem which is called the Bolzano-Grashof theorem and some other theorems about this. Okay, thank you.